Hey, this is Joe, and today we're going to talk about finding the vertex of a parabola. If you recall, if you have a parabola that's concave down, your vertex is going to be the maximum value or the peak of your function. And if you have a parabola that's concave up, your vertex is going to be the minimum value or the lowest point on your function. And the process to find your vertex is kind of dependent on the form of your quadratic function. For instance, let's consider this form. This is your standard form of a quadratic function. And to find the vertex, we simply find the value x, that is negative b over 2a, and we find the value y, that is plugging negative b over 2a into the function and evaluating it. And the vertex of your parabola ends up being the point negative b over 2a, comma, f of negative b over 2a. A more vertex-friendly form is the vertex form. And to get to this form from your standard form, you have to complete the square. And I plan on making a few videos about completing the square, so we won't talk about that now. But the nice thing about the vertex form is we can kind of jump to the vertex of our parabola. In other words, our x value is going to be equal to h here, and our y value is going to be equal to k, and so our vertex is going to be hk. So let's move on to some examples. Let's first start with a standard form example. In this case, let's look at f of x equals x squared plus 8x plus 20. Here, a is equal to 1 and b is equal to 8. Recall that to find my x value of my vertex, I simply calculate negative b over 2a. In this case, that's going to be negative 8 over 2 times 1, which is equal to negative 8 over 2, which is equal to negative 4. And to find the y value of my vertex, I simply take my x value and plug it into the function. So I need to calculate f of negative 4. Which is equal to negative 4 squared plus 8 times negative 4 plus 20, which is equal to 16 minus 32 plus 20, which equals 4. And so essentially I know now that my x value is negative 4, my y value is 4, and that gives me the vertex of my parabola, negative 4, comma 4. And we can plot this above, and we'll just fill in the parabola. Next, let's look at a quadratic function that's in vertex form. Let's consider g of x equals negative 1/2 times the quantity x minus 4 squared, then plus 2. I want to make a note that your x value here is going to be the value of x that makes negative 1/2 times the quantity x minus 4 squared equal to 0, which in this case is 4. And that value can jump at us straight from the original form as well, essentially just looking within the parentheses of x minus 4 and thinking what value of x makes it 0, and it's going to be positive 4 here. And then our y value is just going to be the constant that's left outside, which is in this case positive 2. So y is equal to 2. And so the vertex of my parabola is 4, 2. I can plot that here on the graph, and I'll just fill in the parabola for now. So in summary, if you have a standard form quadratic function, to find your vertex, you first find x, which is equal to negative b over 2a. To find y, you then plug that value into your function, and you get a vertex of negative b over 2a, comma, f of negative b over 2a. To find the vertex of a quadratic that's in vertex form, you first find your x, which is going to be the value of x that makes your a times the quantity x minus h squared equal to 0, and in this case that would be positive h. As you can see, if we plug h in, we eventually get 0 here. And to get y, it's going to be your k term on the outside, or your constant. And so we get a vertex of h comma k. I'm Joe, and thanks for spending some time with me.